Hello, Ravi sir.
Yes.
Actually, first 5 minutes we have to go slow. So some time they will take, but we cannot make late because again after this we have second session there, sir. 7:30 to be start. So our
Okay.
kindly request first 5 to maximum 7-8 minutes. Kindly go slow, sir, so that all will join with this meantime. Okay, sir.
Yes. Yes. Yes.
So now
In
now, sir,
the
officially
yes.
we are going. We will start, sir.
Yeah.
Rahul, sir,
Okay.
please.
Thank you, sir. Welcome to all the participants to the Faculty Development Program on Applications of Communication, Signal Processing, and Robotics for Smart Cities. Welcome to the Day 5, Session 1. The title of today's topic is Wireless Technologies for Smart Cities, Integrating Communication, Signal Processing, and Robotics. And the esteemed expert is Dr. Ravi Kumar Arya. Before I request sir to commence the session, let me have a short bio sketch of the esteemed speaker. Dr. Ravi Kumar Arya is a distinguished professor at Jiangshan Laboratory Wireless Group, Zhongshan Institute of Changchun University of Science and Technology, Zhongshan, Guangdong, China. He obtained his PhD degree in electrical engineering from the Pennsylvania State University, USA. He received his master's degree in RF and microwave engineering from the Indian Institute of Technology, Kharagpur, India, and a bachelor's degree from Delhi Technological University, India. Before joining JUCAS, he worked for several years in academia and industry. He has published over 80 technical papers in highly ranked journals and referred conference proceedings, including 7 book chapters. His research interests include antenna design, computational electromagnetics, machine learning applications, and 3D modeling. With this, I would like to request Dr. Ravi Kumar Arya sir to commence the session. Over to you, sir.
Yeah, thank you, Rahulji, for introduction, and good evening to all. Let me try to see if I can share the slides. Are you able to see my screen?
Yes, sir. Yes.
So thank you, Baby IT, and concerned people to uh, for inviting me for this discussion, especially Professor Nayak and Professor Sumanta Bhattacharya. So here, what? Let me switch off video. So is it in full screen? Is it visible now?
Yes, sir.
Okay. Okay.
Yes,
In
sir.
the starting, you go a little bit slow. Plus, I put some slides that are more towards just introduction. So this was recently very famous video. It went viral, and here what we see is that how the traffic is in China during holidays. So if you see so many cars, like this is toll booth. So what happens during holidays that in China they we have uh, we have all the toll booths are free. There's a little bit sound noise on the background. Dr. Naik, there is a noise in the background. Yes, thank you very much. So basically, in this video, we can see that what happens during holidays. Like there are uh, mainly two holidays. One around February, one a few days back. It was holidays, and this video became very famous. It was a viral video in China, throughout the world also. So here we can see that okay, that people are like merging into lines, and here we can see that the toll booth how the traffic is. And basically, there's a lot of traffic because during holidays, these major holidays, all the traffic booths are like free. You don't have to pay for them, and there's a lot of crowd like that goes from one city to another city because the holidays is like 1 week, and then later on it is 2 or 3 weeks. So during this time, a lot of people travel, and because toll booths are also free, tolls are free at that time, freeways, so people don't have to pay. So there's a lot of traffic, and any traffic like this, we can see that how important it would be that road conditions. If we look at the road conditions, how the road would be, and then how the associated machinery that tells you that how the whole mobility is. Uh, there's a lot of research that is associated with this, where uh, maybe it would be better to show this slide. So some days back, what I was doing that I was checking that sometime on in China they have their own map. Like this is one app named A Map. They call it A Map. So if you see here, then you can see that we can see that how much time is left on the signal. And if you not only time, the time you come to know that how much time is left on the signal. If you book your car like a taxi, even then you will be able to see that if a driver is coming, if a driver is standing somewhere on the red light, you would be able to see that how much time uh, that driver would be waiting there. So so if we look at the infrastructure, the whole infrastructure that might have gone behind it, so you can see that how all these things, there would be sensors, there would be the data would be transferred from through the internet, like how what would be happening. So if there is any app that is tracking the driver, that would tell you the location wise how far that driver is, and where it would also tell you that where the driver is and at what time that driver is. Then with the locations and the time, it would also tell you that where how much time is left in the. So basically, there is data that is also transferred from the signal. That signal is continuously tracked. Okay, that this is red signal, this is green signal now, and when different type of signals are there, how much time is left. That is also basically synchronized. All these things are synchronized, and if we have a like if I booked a taxi, then I would be able to know that how much time it would take, where the taxi is. So the thing is that from the conventional maps where we have like, okay, we order a taxi, then we have to call the guy, somehow we can come to know, okay, where that person might be. But all this synchronization with where the smarter part is involved into the traffic data, all that basically it gives extra edge. So some days back, because it was holiday, so I was walking around in China, and basically when I looked at this transformer pillar, I was really amazed by the. If you look at the lines, the wires, see how good they have been put. So the thing is that in China, one thing I really appreciate that the engineering part, that is, whether it is on road, whether it is in applications like this, or any infrastructure, they they have put a lot of engineering. Like it's not like, okay, you can see that, okay, there might be somebody who really did some pretty good work in order to see that how everything was laid out. So, as we are moving towards the smarter cities, like the topic also says, the thing is, all these things would be small ingredients of smart city, where we would have like data or the sensors that would track that how if something goes bad, it would we would come to know, okay, something happened here. And similarly here, where a lot of data is getting transferred from one place to another, whether it is wireline, it is wireless, there are sensors tracking on different locations. So different locations, like maybe on the red light, or here something where different sensors would be there that would tell, okay, something has gone bad. So all these ingredients would be part of a smart city, where, where according to US Department of Transportation, so it is a network of sensors and citizens to collect data, where all these things can be combined together to make a smarter decision how the things would be, whether it is traffic management, like we saw that how simple map can help you, that how traffic is there, and if something stops on the traffic, then depending upon which like on different locations, the traffic can be managed by looking at the traffic, that how many lanes should be open, how many lanes should be closed. So all these things where different 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 parts of technologies are getting combined in order to make a smarter city, like smart city. So like in other places, like just for an example, like electric vehicle charging, right? So there are some app where we can look at, okay, that if this many kilometers are left, then where would be the nearmost electric vehicle charger where we can go, so that if I have a road map, where I am going to different locations, I can track, okay, these are the perfect locations for me where I should be charging. So all these sensors would be combined, where all the networks would be combined in order to give the connectivity to the citizens, so that we can have smarter choices and open data to share the results, changes, improvement, and data field to the public. So all these things are where it would be helpful, so that we can our life can be much more easier. So in all of this, where the smart cities are concerned, they are different. Like being a me like a being a electromagnet related person, like for wireless communication. So every engineer can contribute to different places. Like they might be sometime electrical vehicle charging, smart parking, where we can know, okay, that which place is open for the parking, how many like if you enter into a parking lot, outside you can come to know how many parkings are left. And it is also possible to know which parking place is covered, which parking place is not covered. Okay, so all these data can be put together, like smart energy. So sometime back, what happened that even in Delhi we saw that the normal meter, instead of that normal meter, the meters became more intelligent, where the data can be communicated directly to the company. You need not to go there and get, okay, what is the reading of the meter. So all these things, different engineers are contributing to different parts of smart city infrastructure. And for a person like me who works with antennas or electromagnetics, we also have role to play. So some of the techniques I would discuss where we are contributing. Eventually, that can be integrated into a smart city. So these are some of the applications where, because we work into software as well as hardware. So these are some of the designs that we are making, like where we are making some lenses, we are making different antennas, we are also making software that would help us to study like lenses or any designs like that. Then we are also making some more software. In the next slides, we would discuss. And this is just some of the features that we use from the machine learning. Like we use data classification, where we have data that can be classified uh, into two classes, then clustered, where we have different groups and different clusters can be made, and data regression, where like we can predict which type of data should be there. Like if it is 20 degree today, yesterday it was 15 degree, a day before it was 13 degree. So for tomorrow we can predict, okay, how the temperature would be or how the weather would be. So those things, those type of techniques are combined together, and in the future, in our recent research, we are combining these together in order to make our life better. And eventually all these things would be integrated, where all these things would help us to make our life easier. So just to understand that with AI into play, that where do we stand and where we are going. And in the recent papers also, I would show that what we are doing now. So currently, if you look at any chatbot like Gemini or any other chatbot, so what normally we are doing, that we give a command something like this prompt, like generate an image of a futuristic car driving through an old mountain road surrounded by nature. And from these chatbots, depending upon whether it has functionality of creating images, videos, and all that, so these are this type of image we can create, that where it can show a futuristic car driving through an old mountain. So it creates what we want to see. And now the trend is also going where, instead of just making pictures, is it possible to make the design, that where we want to make like electromagnetic design, can it make those electromagnetic designs? So like where we were giving a prompt like this, that generate an image, and output we get like this. Is it possible to design a, like, let's assume a patch antenna where I give the parameters, okay, give design like this, and we would get something like this. So this is one of the research that we are doing, and later on I would show some more examples. Currently, this paper is for December MapCon conference. It is accepted, and in this paper, what we are showing is that let's assume that we have a a cuboid or cube or a 3D space, and if that 3D space can be voxelized, like it can be broken into small pieces. So any design, like it might be any type of antennas, it might be frequency selective surfaces, lenses, or any design, or even from other engineering also, any design that we can take. So let's assume we take one filter. So that filter can be broken into different voxels, or and once filter is broken into voxels, so those voxels can be given the material properties depending upon which material we needed in the filter. So what we are proposing is that let's assume we have whole 3D volume, and that 3D volume can be broken into small pieces in such a way that we can create a filter, we can also create a lens, we can create any antenna that we have, or frequency selective surfaces, not only planar antenna that can be 3D, like a horn antenna. So if we are able to run some any such simulations where I take different voxels, and those voxels material can be changed, then it means I can create this geometry, I can create this geometry, I can create this geometry also, all that thing. And if I do just by rudimentary way, I do not use too much optimization, then what I would do, that I would take one voxel, I would change this material. Sometime I can keep it copper like this, or I can make it air, or I can make it dielectric that I'm using for these designs. So they keep on changing with each voxel. Only thing is a rudimentary way, so lot of time would be spent in order to run the simulation. And for the boundary conditions also, I can make them depending upon if I have two ports, if I have one port, multiple ports, the different locations I can define. The idea is that if this type of simulation can be run, then I would get all these designs can be can be trained. So basically I would train the whole data, and I can have if I have that training done, then from the output I will be able to create any designs. So slowly we are going into that direction where mostly the work that is being done is in 2D, and in this work we propose that we can also go to 3D. Now we would have to see that how to run this type of simulation, because it's a lot of data. And this is like a conceptual design where we are thinking that something like this would work. So like we take a volume that is broken into different pieces, and all those voxels that we create, they would give you, like, you can assign different material properties, and then basically you take input data from the user. Okay, this is what I want, and from the AI we would be able to predict. So currently, if you look at that, how where exactly we are standing now, like it's not only like this is a preliminary work that we are telling. Okay, we can do something like this, but the thing is that we also need to see that how much support would be there from the companies that are running this type of. They make the simulation softwares. So recently we saw a lot of work was done in the industry, like like ANSYS being one of the company that leads the simulation uh, ecosystem, and they sometime back they started that okay there would be simulation AI, sim AI that they call it. So then other companies are also working on uh, similar way where they are attaching like chatbot, where like there's another company comes on multiphysics where they are working with OpenAI in order to have the chatbot inside that, so that the designs can be made simpler. Like you can tell it that uh, okay, how can I help you? Create a geometry of a cylinder. So it would give you the code that you need for it. And basically, all the chatbots are somehow getting integrated into the core softwares where it would be easier for the user to interact with these softwares so that it can make life easier. In order to appreciate that how like we propose that design, that how we can use it, and we can also look at that how people are using it in the academia currently, that if we use AI in order to make the life easier. So this is one of the example that was taken, that I have like four antennas, and if the user normally how we run the simulation is that we say that okay, there is some output that we are expecting, and we have some past experience or some mathematical equations that we think okay, this would help us to get the results. With AI it would be much easier if we have the trained data. Then how it would happen is that, like, let's assume I have four antennas and I say that okay, this is the input basically this is the pattern that I want from this combination of patches. So I can give to the trained model that okay, this is the data that I want, okay, and give me the nearmost pattern that you can create from this antenna array. And after the deep learning, it says, okay, that this is a closer pattern that I can give you. So what I did is like I took out of 3D cut, I took one 2D cut, like like one plane, and from that plane I said, okay, this is the pattern I want, and give me from your trained data. Can you give me result that will be closest to it? And it gives you. So eventually, in which direction we are going is that instead of making that rudimentary designs where we were taking the in the classical way, that we would put the antennas, then we would see that how the pattern would come look like. The thing is that here it is still easier, but once if it is randomized random antennas, and number of antennas is large and locations are different, so in those scenarios it becomes even much more helpful to get a pattern like that, or where there is a lot of uncertainties also. Because sometimes if a array is easy, then we can also go through mathematical, we can go by antenna factor and all that, and we know okay how the results would be. But in many areas where there is a lot of uncertainties, then it would be much easier to get data like this. So we talked about a console that is attaching chat gpt. There is another company answers that also having their own sim AI. Then another company that is very famous is MathWorks. They also started to put a lot of data inside their online help, and they are also creating a lot of modules. One of the module that was recently last year, it was presented in APS. So what they did is that they said that mostly what happens that when we take a data sheet, in the data sheet of an antenna, like we bought an antenna and the data sheet would come with that antenna. And from that antenna data sheet, what we would have is that they would give you two cuts, like azimuth or elevation cuts. And what we see from there is that we only have these 2D cuts. We do not know how the 3D pattern might look like. So what they did is that they have like deep learning model where they say that okay, if you give the 2D pattern, From there we can create the 3D pattern. So different companies are coming up with different uh, machine learning modules where they are attaching it to their core software in order to make the life easier uh, for the users. So for us also, like we are also working into, like where we are working into, mainly we work into electromagnetics, but we also for some time back we started to venture into AI, like using different algorithms in order to see whether we can integrate them and get much more easier or cheaper designs in electromagnetics. So last time we proposed that we can also have a AI based antenna design software, and we called it Antenna Guru. So what it is like is similar to a chatbot where you say that okay, this is the design that I want. Like I am designing a 4 element array at 26 gigahertz, and I want to enhance its performance by using a meta surface superstrate. So what we can do is that with this, if we have the trained data, then what would happen that okay, you tell us okay, you tell the software that this is what we want, and from that it can give us the final design. And a lot of work going into similar type of work where you give that these are the final like parameters, like I want the gain from this value to this value, and I want antenna of maybe planar antenna. So it would be easier to give designs. If not now, in the future, it would be we would be able to see that type of software where you give the output, this is what I want, and it would give you the design. So recently, we what we did is that we also did another study, and this was published in APS. And what we can see here is that let's assume that I fabricated one antenna. Like it's not just antenna; it can be any other in any in other engineering also. There can be designs that is made. Here we use it for electromagnetic, but it's a general process that can be used. So what we did is that we made antenna like this, and what we say is that it might be possible that there might be fabrication faults in any design like this. Like let's assume that I had to make this split ring resonator. So instead of creating it at k value, it might be k plus minus delta, some value. It got fabricated where when I made the design, somehow it moved to some other position, or it moved to any other position. So what we do is that in order to make the design simpler, we say that okay, that this resonator moved other dimensions, we are thinking okay, they would be same, everything would be uh, fabricated all right, only these dimensions would vary when we fabricate it. So what happened that this is a typical problem that can happen into any type of engineering, not only in antennas. And the problem is like if we see here that mostly what we do is that we make the simulation design and we expect that the whatever simulation design was there we fabricate it and we should be able to get the similar result, and that's why the user is spending so much money on these all these softwares. So if the design is not as expected, then it means that software, sometimes we think okay, software did not help, or sometimes we did not make the software was not right. So all that money that is spent into software as well as the fabrication, even the measurement, sometimes it might not be easier to measure. So there's a lot of resources that got wasted. And for in our case, where we are working into, we have this design, and if these designs are for very high frequency, then this type of small fabrication fault, where there was a uh, error. So this error would be even more. It gets more pronounced. Basically, it's where it is much more higher when we go to higher frequencies, because in lambdas those errors that we might have due to, instead of k it becomes k plus delta, that delta k would be much more larger in terms of frequency, in terms of wavelength, but basically when we go to higher frequencies. So the thing is that it, it's a very big problem, and we thought, okay, can we use machine learning into it, and in order to help us whether we can. So we simulated some design, we fabricated it, and then we measure it. Is it possible for me to know that there was some problem somewhere? So what we did do is that we made this simple design in order to see that, okay, we would make this antenna, and we would try to know. The thing is that this problem is still easier if it is some design like this. But if we had multi-layer design, then then it would be difficult to see that where the problem might be. Because if it is just a design like this, I can go through microscope and I can measure that how much distance was there. If it moved, if it changed, then I can, through microscope I can check it. But if it is a multi-layer design, then I cannot check it. And if it is uh, so it means that if it is multi-layer design, I would have to break it. I cannot look through it by like naked eyes, or I cannot look at it through the microscope in order to know where the problem might be. And if the design is also very complex, then also it would be it will not be easier to pinpoint where the problem might be coming. So in such cases where we do not want to destruct the device that we are going to where we are checking whether it is it is similar to what we it is same as what we simulated. So then in those cases, instead of destructing that, where we can, so we can use non-destructive method. So what we propose is like, okay, we can use non-destructive method where we need not to break the device. Like I need not to break it and try to know, okay, where the layer might, which part might be not fabricated right. So what we can do is that we can use machine learning algorithms in order to predict that where the fault might have been. In this case, if we take only two parameters that might have, these two dimensions might have changed, so it would be easier. So what we do is that we take these values, we change different values of k, we change the value of k and g, and other dimension we think that, okay, there will not be any problem. And after this, we basically train the data, like we create a lot of data, like we keep changing the value of k and g, and this is the data that we create. Now exactly what happens, how we come to know. So let's assume this was the simulated data. Okay, instead of that, first go by measure. So we created this design, we measure the results. We said, okay, this is the measure result. So from measured result, I can predict what might be the K and G values. I know that what is the K and G values. Like I can come to know because I have the trained data. I can predict that what I can from this measured data. I can through the machine learning trained model. I can come to know that what is the value of K and G. So let's assume we get okay. So we get K1 and G1 value. Like we had K and we had G value. So we have now K1 and G1 value. And we also simulated some value. So let's assume that was K0 and G0 value. So if these values are not right, then what we can say that if there was no any other errors coming from other uh, dimension errors, so what we can say that if K0 and G0 is not right, if it is not same, then there was some deviation that came from fabrication. And how much deviation came from this, we can also say by looking at the difference between K1 and G1. K1 K naught and G1 G naught. So in this way, that machine learning algorithms can be helpful. It's not only tied to this type of design, it might be another designs also, like in mechanical engineering, it might be like where we check the stiffness or elasticity we check, where we simulated a design and it was not same. So then we can see that from where, like here the dimension change, there also we can predict that where the problem might have come. So this type of study can be very helpful. Now the thing is that, so till now what we saw that there's, in the smart city, like it would demand different modules, and in those modules wireless communication, in the wireless communications we would be looking at what is coming from electromagnetic side. So it's for us because we are designing hardware like antennas or something, that itself is not enough. Like we also need, in order to make the smarter designs, we also need to venture into software design, where any complex design like this, if we say it's not easy to design something like this. So we started to make our own software also. Like we would make fractal antenna designers, or we make like Rotman lens designer. We made some time back software. So with these softwares, designs, making the designs becomes easier. And in order to, because there's a lot of work coming from open source community, there's also these companies who are working together. So they also are making the modules in such a way so that it is easier. That they are making the life easier for the users. And here we can see there is a one, sometime back ANSYS started their one software, like it is called PyADT. Basically what they did is that instead of manually making the design, can you streamline it through scripting so that design can be, you write a code and then design can be made automatically. You need not to manually create the designs, and we can see here in the video how it looks like. So you have the code and then you run the code and then it creates, it shares, okay, it is initializing the HFSS. So we do like this. So like it would open the project, insert the project. All this would be automatically written in the code so that everything would be running. So if you are making different structures inside it, it would make that, and we can see here how fast it is putting everything together. So depending upon how, which type of script you have written, everything would be made like this. So the idea is that whatever we are expecting into that smarter world that we want to make, everybody has to contribute. All the software companies would have to contribute, and they are also going into that direction where we cannot just manually keep on making the designs. We also have to automate it, because if we are making so, putting so many sensors, so many hardware behind it, the software also has to be there. Then the speed of the data, the capturing of the data should be there. So all these things are coming from the different entities, engineers also working, these software companies also working. So all that is coming together. So what I am showing is that we are showing that from our domain, how, what is the progress that is going. We are also making that progress, and other companies also contributing to it, so that we can reach up to that goal, that okay, how the smarter cities would be. Other, what would happen that okay, the world will go, we make the specification, okay, this we want, but the hardware will not be there. So all these things are coming from the different companies, where students are contributing, companies are contributing, and everything is going on. So for us also, we found that okay, we cannot keep on manually making the designs, like any designs that I showed earlier, like a Rotman lens. This type of design, it's not easy. Normally, what happens in any engineering, like let's assume I have a project and I told my students, okay, make this design. So the normal process is that they manually create the design. But the problem is that sometime from the if I got that project from a company, they would say, oh no, instead of 5 gigahertz, they should be working on 10 gigahertz. Now, if I made that design manually, then the thing is that I would have to recreate the whole geometry. Like students, I would tell them, okay, instead of 5 gigahertz, it's a 10 gigahertz now. And the whole work now, it's a lot of work now. So what we started to do is that we would make our own software. We started to move all these things into scripting so that the designs. Otherwise, I give you one example. Like if I some design like this where the design is very complex. If we give the same design, if I have the even the dimensions of this design, if I give to 10 people, all these people might have different results from this design. So what we basically I was working in companies. So what we realized is that we cannot go by the manual way, the way we are designing the designs, these structures. It would be much more helpful to script them. So if I give the same script with a similar software to all these 10 users now, we would get the same design, same results. So like if we ran this script, like this script, anybody if the software is same, basically it does not change much from one version to another version. So if the software is same, if I run this script, 10 users, they would get the similar result that we see in the last. Same similar result we would see. The thing is that when we are making it manually, then the designs do not match. Different people have different, sometimes the dimensions might be wrong, sometimes the software that they are using, the boundary conditions that they are using, the number of port that the type of port that they are using, that might be different. So there's a lot of abnormality that can enter into the design. So what we found is that okay, we would make our own software. We would also move into more towards scripting side, where if I make the script, I run that like we showed with ANSYS, we would get a similar design every time. So even instead of scripting, then we also put a face on it. Like we put a GUI so that the GUI can be interacted with the scripting that we have in the background. So that if somebody wants a GUI based design, then it would be easier to make them like this. So these are some demo software I'm telling you that where how we are contributing to that research. Then we also work into different antenna, like we work into lenses. We make antennas. We also make lenses. So this is few lenses that we made. Like one of the problem that I can discuss here is that normally what happens that when you make lens, then what we do is that we have plane wave coming from one side and we have the thickness of the lens that we need, and we say okay, this is the focal point where the all that plane waves that are coming from the left side, they should basically focus at this point. So what happened that according to the need, this thickness, this focal distance, and this diameter of the lens, we have to decide what would be the dielectric constant that we need for the lens. But all these dielectric constant might not be available. Many times it happens that we do not have those dielectrics. That if we go to let's assume we made a design and these were the values that came out. I'm just showing some results from the Rogers dielectric values that they provide. So if I want to use, if I need now 3.46 for this lens, then we do not have value. So I would somehow use another, any of those that would be closer to 3.46. Similarly, 3.25, I can use 3.27. So different values that would be closest, I can use it. But the thing is that I do not get the similar value. So what happened in the recent other, because other engineerings are also moving ahead. So there was a lot of work done into into 3D printing also. So if I have any material, maybe like whose the highest dielectric is around this, then what I can do that I can put some air inside it, like in order to understand it better. We can have one example here. So it's just like a meme where what a great hygienic man, he's washing the milk before selling it. So normally what people do, right, that they, in order to increase the volume of the total milk, then they would add some water into it. So similar process can be used in our case also, where we can mix, like we have water as well as milk. We combine it together and we can create any dielectric that we need from the highest to the lowest value that we need. So like here we can see that we have like 3D printed antenna, 3D printed lens. What we do is that we take the material that we can 3D print, and then we put the air voice inside that, so that the equivalent behavior of this air void as well as the 3D printed material would be closest to the what we want. There are different dielectric values that we need. All these values, they can be created by mixing these air voice as well as the 3D printed filament. So we made some lenses in the starting, and sometime it can also happen that by this what we can do is that we have the highest dielectric. By putting the air, we can make lower dielectric constant material. But then there is another way to make even the higher. So what we did is that with 3D printing, instead of the conventional techniques, let's see how the conventional techniques are. Like you take a design, then you get the material, we machine them, assemble them, bond them, and test them. So what happened that with 3D printing, if a few of these steps are taken away, like whatever we had, source material, machining, assembling, bonding, all that can be replaced by 3D printing. So what happened that here when we had this uh, uh, the design, so it became easier for us to make any complex design like this now. Like if we have a 3D printer, we can make any complex design. We need not to cut them, a lot of wastage and all that. No need to do machining and all that. So 3D printing can help. So in 3D printing, basically what happened that you have a nozzle that would get heated, then we have a filament that is pulled, and that heated filament is put together. Like additively we add it and make a different layers, and when these layers are combined together, we make the whole design something very complex like this. So layer by layer, from the bottom as we go up, we can have any design that we want. Any complex design can be made. And in the past, we made something like these designs, lenses, and different types of lenses, reflector is, transmitter is. We worked on them. So I think we can skip this part. So this is just to show that we made different type of reflectors also. Like you can see here. Then we also continuously keep working on different type of lenses, where this is one of the lens that we made. Like it is called Leonberg lens. And the property of this type of lens is that if you have plane wave coming like this, it would the lens would focus the waves rays on the diametrically opposite end. Like it is coming from this side, it would focus it here. If it is coming from this side, it would focus it here. And the dielectric constant that we need for this lens is like it. If we put that here, if we look at the equation, so if r is equal to 0, then it becomes 2. So basically, at center, the dielectric constant is 2, and as we go away from the center, it becomes 1. So with this, what we say is that if we have any for 3D print, if we have a 3D printer, and if we have any dielectric constant that is around 2 or lower than 2, around 2 or higher than 2, then around 2, then we can make any lens like this. And the good property of this lens is that, like we were saying in the receiving mode where we have the plane wave focus, if we are in transmitting mode, it means that if I have a source here, antenna here, then what would happen? It would send the wave in this direction, and if it is here, it would send the wave in this direction. So with that, basically, how, like we have low Earth orbit satellite communication is there. In that, what we can do is that we can, if we have different antennas here, and if we are receiving or transmitting, then what happens that depending upon which direction we are getting the beam, we can scan, we can steer the beam depending upon which antenna is active. So in this way that we can get the beam in different direction, like here we show in the different direction. And other good thing about this type of lenses is all these gains would be similar because it's a symmetric design. So if I put a feed here, or if I put a feed here, and that feed would be basically generating the pattern that would be similar. So this type of lenses also we are currently working on, and there are different ways that these lenses can be created. Just a minute. Basically this one. So what we have is that, so we can 3D print, like we had half 3D printed lens, half 3D printed lens, and we combine that to make it full lens. Or we can even have laminates where, like PCB sheet, and by cutting the holes, like I told earlier, that we can mix the material as well as air. So here also it is similar to that we put a hole inside the laminate, and then we can get different dielectric values, and we put them together 3D print, or like we can cut the holes inside it. And for lower values of dielectric, because at the end of the lens we need dielectric values that is very low, like here we can see that is around 1.1. So normally with these material it might be difficult. So what we do is that we take the foam, and we at the for the low outer shells we can use the use the foam in order to make it. And in order to feed these lenses, we have different array, antenna array. So each element, depending upon which element would be active, then we can send the beam away from diametrically opposite end. So by combining all these lenses or different antennas, we can get the, like depending upon how big this lens can be, we can get the desired gain. And this is the radiation pattern that we measured, like simulated and measured. One of the other things that are helpful is that we also do research on measurement techniques where we have robotic arms, like here we can see this is also robotic arm. So we have the robotic arm where different algorithms we are creating where we can get faster results. Or we have anechoic chambers where anechoic chambers uh, are studied in such a way so that we can get cheaper designs. Like it would take less time with less noise and all that. I think I can mm, leave this slide. Other work that we do is that it is based on CAD. Like we also work on computer aided design where I can show something like this. So where what we do is that we in 3D printing, if somebody works in 3D printing, they might have seen that in order to 3D print something, there is a very famous 3D printing 3D format that is used. It's called STL, and it is STL is like S, T, and L, stereolithography. So this is one of the 3D file format. Like you can save the file, and depending upon how, because it's made of triangle. So what do you do is that you give different vertices, and from these vertices you make the whole 3D geometry. So what we are doing, that we are also venturing into this. We work into, basically for some time we are working into 3D modeling also, where 3D designs can be made. And one of the example we can see that there's a one design named Butler matrix. So what Butler matrix does is that, let's assume that I have, it's a matrix basically. You have, like here we have like transmission lines, and here we have different antennas. Like I have one, two, three, four antennas here, and these are the transmission lines. Then transmission lines are connected to these antennas. The idea is that if I change the location of the feeding, so I feed from this side, I feed, and depending upon which feeding point, like the port is active, whichever port is active or excited, I can steer the beam. So, like we see in smart city, like when we in the starting slide we were showing that basically we do not want to. There are some application where I do not want the beam, like the beam to be always in one direction. I want to steer it so that if the user is moving, I should be able to move my antenna also. Basically, this antenna should be able to focus into that direction where the user is moving. So in those cases, basically this type of structure is helpful, that I change and keep on changing the port, and the radiation is more directed towards particular user. So what this matrix is a combination of different components, where we have couplers, we have phase shifter, crossover. So what we did is that we basically this design becomes a little bit complex. It's like you make it, and then other thing is that because if it is a manual, yes. So the thing is that if it is a manual design, then what happens that if frequency changes or your design parameter changes, then you have to redesign it. So what we did some time back, this work we published in conference this year. So what we can do is that we can break this geometry into triangles, like I showed earlier in STL file. We can break those triangles. The STL file is made of those different triangles. So we also break it into triangles, something like this, and we automate. Like we write it as a code, put everything together, and we can make all the different components of this matrix. They can be combined together, put it into to a script, put everything together, and we can make a matrix like this. So the thing is that combining softwares with the hardware, the fabrication of the structure, the design of the software, design of the structures can be helpful. It can be much more automated. So we are automating this type of designs where it would be easier to make them. And then if it is very complex, something like this can be designed. Apart from that, we also have some other lenses. I think we can leave some minutes for discussion. So we also make different type of lenses. Like here we can see that these hollow spaces basically, because earlier I told that we can make different dielectric values. If the dielectric value is very low, what happens that the 3D printed material that you use, it is very thin. So here we can see that it sometimes it does not get printed, but eventually we saw that results were quite close to what we were expecting. Then we also work into different type of designs. So all these things, all these designs are helpful, that would ultimately contribute to any design that would be used for smart city infrastructure. This is one of the recent design that we made. It was uh, presented in APS 2025. Then we also work on measurement system. Like we make different type of antennas. We also make measurement system. We work on the measurement system where the software is improved in order to get faster or cheaper, like less resource hungry designs. So this was the work that we did, that was published this year. Then we also work on different robotic measurement, like we use them as well as we also improve them. So with all this software and hardware, so what we are expecting is, like, this is just one of the thought we had. Eventually, this is how the softwares would become. Like, you tell me that, okay, this is just a demo, but it can be applied to more complex designs. Where what would happen that you give me the frequency, the gain that you want, frequency that you want, and you tell us, okay, this is the number of shells that I want to make for a lens. Then tell me how, which type of design it would be. So what we can see is that we can predict, okay, this type of design it is. And if I have any software also integrated with it, I can even run the simulation and I can see whether the input parameter that I gave, whether they match or not. So something like that can be done. And this would be very helpful for any designers where they do not want to buy the software. We just make a small module. Okay, you are making only planar antennas. Let's make a module for you where you don't need to buy any software. We integrate in such a way for you that so that you get everything that you want to design. So I think we can leave some minutes for discussion. So this was the main thing that I wanted to present. This is our uh, maybe I can show a few slides from our lab. So I work in XSL lab. Basically, its full name is Xiangshan Laboratory, and we are near to Macau. We are in Zhongshan. We are closer to Macau or closer to Hong Kong. Like if I have to go to India, so normally what I do that I take a ferry from here, go to Hong Kong, and then we can have there's a direct flight from Hong Kong to Delhi. So we are near to Hong Kong, or there is another airport that is closest named Guangzhou, and so we are a new lab that has been established in south part of China. There's a very famous city named Shenzhen. Most of the electronic stuff comes from Shenzhen. If anybody knows a little bit about China, so most of the electronic stuff comes from this city, and we are very close to this. And we have most of the hardware or software that are mostly used in the industry. This is our lab, how it looks like. We have some demo hardware that was created in the past. This is the near field measurement system that we have. This is inside the lab where our one of our engineers is working, and this is our far field chamber, and this is some of the robotic arm we are using for measurement. Thank you very much.
Welcome.
And if we have any questions, we can discuss. Yes, sir. So any questions?
Any questions, please ask, sir. Sir, myself has one a small doubt, sir. Ravi,
Yes,
sir.
yes, yes.
Sir, if we are using GUI and a program, etc., whatever you told, I think there is no, even without antenna knowledge also, without knowing antenna engineering, without knowing anything also, one can design also a good antenna, sir. That means my whatever I understood, no need of, even if one like this electrical background or maybe computer background also, or if he's expert on programming, if he's expert on how to operate any GUI, then also he can do. No need so much of whatever we are studying, that fundamental wise, sir.
You
He
see,
can be expert also. No? Any antenna he can design that, I felt, sir. Nowadays,
okay.
whatever technology came, sir, no need, because previously we must know all the design equation. Even
Yes.
designing one microstrip patch antenna also, we are writing equations, we are doing this. And first we are simulating any software, then but nowadays your technology is so much advanced, no sir. So what I
Hmm.
felt is, even one if one knows that the technique how to operate, only he knows this these are the technique. One even without antenna engineering knowing also communication without
Yes.
any background also it can be a good design, I think. But I felt, is it true or I missed somewhere there?
Yes, yes. So I can tell you my past experience. What what I saw. Okay. So like it's a very good question. And in one of the presentation like this, one professor told me that he said that in VLSI, even the professors who are working in VLSI, because it is easier to get papers in antenna design. So what
Yes
they
sir.
did, even if they are from VLSI, they are publishing the paper in antennas,
Yes sir.
right? And that we see also from other domains also. They say, oh, it is easy, okay, make something somehow,
So
port
something
here,
do, graph will come.
right?
So something will
Yes.
come.
Okay, make it
Yeah.
complex. Make it
Yes.
complex, you would get the design. See, there the thing is that, see, that's why it is very hard for students to get employed in the industry.
Yes sir.
What has started to happen that these people, some people, okay, not everyone, but some people, they started to take advantage of this type of behavior. So now
Yes
what
sir.
happened, even if they did not have any quick chamber, they did not measure it, they created the result,
Yes sir.
right? And we know, we do not want to point fingers on us or
Yes
you
sir.
and me and all that,
Yes sir.
but
Yes
that's a
sir.
reality, right?
Yes sir. Yes sir.
So what happened that somehow we are losing that knowledge that we could get, because
Yes sir.
fabrication is art, measurement is even like it's a black magic. Sometimes it might not work and you have to
Yes sir.
see. The thing is that real learning happens when we fail,
Yes sir.
right? And measurement is a that field where we fail many times and we learn, and people are not learning from that. Now coming back again to your question, the thing is that all these softwares, why we started software development for us. One was that my professor in US, they were making software, so we made software. But I came to India and then I saw that for BTech students, they do not want to go into hardware. Plus, it's
Yes
very
sir.
difficult. If I have to teach them, okay, antenna design, they should already should have gone through the courses, right? And then they should have known the field. And if I tell them, okay, make something new, it takes a lot of time. So what I thought, how can I help them? I should make something that where they feel that okay, they are learning something, where it can be used into their employment.
Yes sir.
So we started all this work was done by bachelor students. Everything.
Yes sir.
It took a lot of
Fine.
time.
Fine.
It took a lot of time to train them, but once they were trained, so all these
Immediately
students,
output will be.
just see, just this year, two students graduated. Both of them went to ISC. After BTech, directly into MTech. That was the best institute that they could get in India. My point is, see, if we are looking for the easy route, life will not be easy,
Yes sir.
right? So it goes with all these people who are trying to run somehow, right? Okay, we would take a shortcut here and there, but that cannot go on for long. For professor, it might be done. Okay, for them, what they need papers, but the
Yes
total
sir.
loss is for the students because they did not learn.
Mm.
And those students have to realize they had to make their life, not just publish one or two paper. So with all these things happening in surrounded where in surrounding of us, the thing is that we should work hard. It's not just
Mm.
okay, we cannot just make the software. If we do, the thing is that even if I make the software, right, but if I do not have the fundamental knowledge that how
Yes
the
sir. Yes
signal
sir.
is passing, right,
Finally touch.
how where it might be acting as an antenna, where it is working as a transmission line, I cannot succeed much. Up to one level I can go, but on international level, if I go, there would somewhere I would get caught. And there are many people we see, they do on international arena, they do not discuss anything because they know that okay, they faked it. So as a people who really want to improve themselves, for the students also, those who want to improve themselves, I think they need to read everything. Even if they are antenna designer, they cannot just say, okay, it is software. We will not need that knowledge. We do need that knowledge. Otherwise, it would be just software. We do not know how it is working. So this is my just like what I learned and what I
Yes,
learn
sir. Yes.
every day. Any other question?
Anyone?
If anybody wants to post in the comment section also, we have
We can.
a few. Yes, you can also post here.
Hello, sir.
Yes, ma'am.
Hello.
Yes, ma'am.
Uh, yes. Myself Nivedita Mukherjee from EC Department, BBIT.
Yes,
Sir,
ma'am.
one question. Basically, I want to know that the 3D printer, that the dielectric materials, how
Yes.
can we optimize for this?
Yes. So normally, see, normal material that we use is PLA. Is dielectric constant is 2.7. Normally it's 2.72 or something. Let's assume 2.7. Okay. So we have, if I take a dense material, like if I make it full, the whole material, it would be dielectric constant of 2.7. So now if I make break into unit cells, if I put a air inside it, I can decrease it. So that's what we do. That wherever we need to decrease it, we put more air. So it's like okay, 2.7 and air. In between, if I could keep on increasing the volume of air, it would come. I can go from 2.7 to 1. So depending upon how much air I fill into that unit cell, I can change its properties. So easiest would be buying normal printing that we use is PLA is dielectric constant is 2.7. There is a loss part also, but just looking at the dielectric constant, we can go from 2.7 to the lower dielectric constant. So there are different techniques to make it. We just follow those techniques and we can make it. It's like mixing water and milk. So milk is 2.7 dielectric constant PLA. The more water you make, it would be lighter, like it would be closer to water. So we just mix and match. There are different papers. If you say, I can even send it to sir, that you can go through to make this type of design. But it is easy. Just mixing that 3D printing material and air, we can get different values of dielectric constant. Ma'am, is it clear? Or any other question? Sir, you are mute.
Sorry,
Please.
sorry. Anyone want to
Yes,
ask
yes.
anything? You can ask. Otherwise, okay, sir.
Okay, thank you.
Suman
Thank you,
sir, you
Imran
want to
sir.
ask anything?
Yes, Samantha sir.
No, sir. Excellent presentation, sir. Sir has done
Excellent,
a
sir.
lot of
Excellent
work on
work.
that
Sure.
field.
Samantha sir, you are getting younger and younger with age.
Thank you, sir. Thank you. You too,
Okay,
sir.
okay, thank
Thank
you.
you.
Thank you
Thank
Thank,
you
for
very much, sir.
coming.
thank you very
Yes,
much,
Thank
sir.
you.
thank you, Dr.
Thank you very much, sir.
Okay, bye. Bye. Bye,
Bye. Bye,
guys.
sir.
Bye. Bye.
Actually, sorry, I am. You could not send attendance. Just please give 1 second. I forget actually today. We forget regarding. 1 second, please. 1 second, please. Please all give the attendance. Actually, I forgot to give the attendance today. All kindly give their attendance. Already attendance are plotted there.
Hello, can you hear me?
Hello, good evening, madam. Hello,
Good evening.
I am Deepak, madam, Deepak Kumar Naik.
Thank
And
you.
Sumanta sir also there.
Madam, good evening.
Good evening, Sumanta. Thank you.
Welcome, ma'am.
Welcome, Rahul.
Thank you, ma'am, for giving us a time for this.
It's a great honor.
our HOD madam also. Pariti madam.
Good evening, madam.
Good evening,
Myself, Kapil
Kapil.
Gupta Das.
Thank you. Kapil Chan.
Nice to meet you.
Nice to meet you too.
We will wait for attending more participants.
No
Sir, not
problem.
audible, ma'am.
When you are ready, let me know.
Okay. Sure.
Yes, we can. We will. Rahul sir.
Rahul sir, please.
Madam, can we start? Officially, we will start. Selva
Yes,
madam.
sir. Yes, sir. Yes, sir. Please start.
So good evening to all the participants once
Yes, sir.
again to the day 5 session 2 of the faculty development program on application of communication signal processing and robotics for smart cities. The today's title of the talk is deep learning for smart healthcare. And the esteemed speaker is Dr. Sylvia Sahmaj, Madam. So before I request Madam to start the session, I would like to briefly introduce the biosketch of Dr. Sahnaz Madam to all the participants. Celia Sahnaz Madam is a fellow SMIEEE, received PhD degree from Concordia University, Canada, and is currently a professor at Department of EEE, BWET, Bangladesh since 2015. She was the winner of Canadian Common Scholarship for pursuing a PhD study in Canada and recipient of Bangladesh Academy of Science Gold Medal for her contributions in science and technology. The World Academy of Science members have elected her as the Fellow of TWAS for the advancement of science in developing countries, effective from January 2023. Recently, her nomination has been approved and she has been inducted into IEEE ETA company as a professional member into the ETA chapter of the Board of Governors. She has been selected as 2025 IEEE Computer Society Distinguished Visitor. She has been appointed as 2025-26 Chair IEEE WIE Nominations and Appoints. She has been elected as 2022 IEEE WI Committee Chair-elect and she has served as 2023-2024 IEEE WI Committee Chair. She has been appointed as 2024-25 Division Representative, IEEE TAP Award and Recognition Committee, 2024-25 Member, IEEE 4-Year Award for Signal Processing Committee, 2024-25 IEEE Computer Society Awards Chair, 2025 Member, IEEE Diversity and Inclusion Committee 2024. So she has served as 2021 Chair IEEE SPS Women in Signal Processing 2021-22 liaison between IEEE SPS and IEEE WIE 2021-22 member, IEEE Educational Activities Board Faculty Resource. So she has also the recipient of 2021 IEEE MG Achievement Award, 2021 Inspiring Women in Academia Award from Bangladesh Brand Forum, 2019 Art and Humanitarian Activities Outstanding Volunteer Award, 2016 NGA Leadership and 2015 WIE Inspiring Member Award, 2013 Art and WIE Professional Volunteer Award. She has more than 24 years of experience as IEEE volunteer in leading impactful technical, professional, educational, industrial, women empowerment, humanitarian technology, power, and energy-related projects at national and international levels. With this, I would like to request Celia Sahnawaz ma'am to commence the session. Over to you, ma'am.
Thank you, Rahul, for such a humble introduction. I like to thank Sumanta for connecting me with Dr. Deepak. Thank you, Deepak, for taking this great initiative, and thanks to Head of the Department, Kakuli Sengupta, and all participants here. It's a great honor to be here. Hope I'm audible to all of you. If so, let me share my screen very quickly, and please confirm that you are able to see my screen.
Yes,
Or
yes, yes.
Yes, madam.
able to see
Yeah, yeah.
changing. Is
Yes,
it
yes.
changing?
Sending it.
Okay. So we are ready. Thank you very much.
Yes.
Actually, this type of program is very, very important for knowledge dissemination, especially area application of communication, signal processing, and robotics for smart cities are very close to my heart. So I have chosen the planning for smart healthcare, although I cover many applications related to signal processing, robotics, which are very important for smart city. Uh, just on October 3rd, this I've been awarded for 2025 IEEE Region 10 Quality Capacity Outstanding Volunteer Award. This is the highest honor from Region 10 for any professional member. I will request you to visit my Google Scholars citation, Google Scholars Celia Shanaj. Then you will get my Google Scholar profile that really help you to let me know, to know about my research so that we can really further collaboration. It should not be just a 1 hour faculty development program. And this is my recent appointment for this year to the Computer Society Award Board Chair, and I'm serving as Computer Society Distinguished Lecturer, which they call Distinguished Visitor. These are some of my individual and group award, and especially since I'm talking about healthcare, let me focus Engineering, Medicine, Biology, Bangladesh Society chapter. I'm the chair now, and I was one of the founding members. In 2020, we received IEEE MBS Regional Outstanding Chapter Award. I'm also founder of IEEE Signal Processing Society chapter, and we received the chapter certification very early under my leadership. Let us share with you what we are doing along with my students. By the way, I serve as a professor in the Department of Tripoli, Bangladesh University of Engineering and Technology. That is the highest ranked engineering university in Bangladesh. So for healthcare innovation, we are focused on technology that is really portable, affordable, easily accessible, sustainable, and scalable. So first of all, let's see the wrist card. This is a kind of wristband, and that will give you all health related data. Another is digital stethoscope for cardiac signal measurement, so that you can also, staying at home, very quickly communicate with your doctor. Another is non-invasive glucose estimation, because a lot of people are suffering from blood glucose, I should say diabetic, pancreatic cancer, liver cancer, like that, liver cirrhosis. So measuring blood glucose using an invasive technique is very difficult, and glucometer is also very expensive, not affordable by everybody in the West Bengal, Bangladesh, or anywhere. That's why non-invasive glucose estimation is very, very important research. And talk about smart injection device, so that the needle position or vein position can be tracked through a camera, and angle can be changed, so that even if there is a non-expert nurse, the injection can be pushed without injury. And that is very effective for a mass vaccination. We have faced largest Rohingya community in Bangladesh. So in that cases, this is very important for handling such community where mass vaccination is required. And also in our rural place, the eye vision testing is very not comfortable and easily accessible. So we have designed a voice-based eye vision tester and also automatic vein detection for pushing the injection. Let us see how we can support the healthcare to the disabled people in the community. If we want to make the city smart, they are an important citizen. Smart wheelchair. If you look at the wheelchair available, those are very expensive, more than $2,000. We have done something that is reduced down to 200 US dollar, and you can run the wheelchair by voice, by your eye gaze, and by your brain signal EEG. And for brain signal, we have another device that is called brain drive to handle the education of the autistic people, children. We have devised Canvas Life that will help learning development of the children. You know, at our home, we live far sometimes from our parents and from our in-laws. So falling down in the washroom and the kitchen by the elderly people is a common phenomenon. So we have designed a smart hat for elderly people to afford a smart life for the senior citizen. Moreover, if you want to uh, enroll the disabled people in the industry, so we have utilized their brain signal to create 6 commands sitting in the wheelchair. That's called opening the door and doing something. That 6 tasks, 6 control signal will be related to performing 6 tasks. Also, we are very much important in a smart city to give the opportunity to talk or to educate, to have entertainment by all group of people, especially who are blind. So for them, we have designed Bengali Sign Language. We have developed a Bengali Sign Language database, and we have developed an automatic detection of Bengali Sign Language. And also look at our blind people. The sign language was for our deaf and dumb people. And for blind people who are not able to see, there are a lot of literature in the English blind using sensor, actuator, like that. We have designed this Bangla Braille to afford the education, to create the opportunity of the blind people who are speaking Bangla. Bangla is a 5th or 6th ranked language around the world. So this is very, very important. And for Bangla is a language for which we have dedicated our life in 21st February 1952. That has really motivated me to develop this Bengali Sign Language and also for Bengali Braille. Let us talk about innovations related to IoT, robotics, agriculture, and climate change to smart city. One is rail crossing system based on sensors, actuators, like lag. Another is very important for avoiding giving alarm in the accident prone areas. And also women's safety is a common issue. And it is really, we have to continue addressing it. And due to climate change, dengue mosquito is the threat of lives in Bangladesh in many areas. So we have developed a drone that will automatically detect a dengue breeding zone and throw the medicine accordingly. In our halls, in our residence, there is a huge problem of theft. So we have designed an anti-theft detection algorithm that can be set in a motorcycle, bike, or anywhere to create or to avoid such theft. And when there are rainy season in Kolkata and in Bangladesh, roads are jammed with water. And forget about villages. There are muds and other things. So we can at least devise or use the robots that we have developed to find or collect waste from the ground or from the water. Although from the water, we need a proper propeller design. Recently, last year, we have developed a robot that will classify weed from the paddy field, and that is very, very effective for effective and efficient cultivation in case of agriculture. So these are some examples how we can utilize technology, communication, deep learning, signal processing, IoT, and robotics for our smart life. So let us see, after the COVID, that became a common phenomena of hypoxemia severity. Hypoxemia means low blood oxygen. So it is very critical in case of hospital inpatients. So we have proposed ResAC-ConnNet, a deep neural network for hypoxemia severity prediction for hospital inpatients using PPG signal. Hypoxemia means low blood oxygen, and it is related to cardiac arrest, and it is really fatal. So a prior intervention is very much needed. That's why we have proposed this deep neural network, and this work has been published in IEEE Journal of Translational Engineering in Health and Medicine. Another is detection of COVID from different imaging techniques like X-ray, ultrasound images, and CT images. So for this, we have published this paper, CAPS-CoVNet, a modified capsule network to diagnose COVID-19 from multimodal medical imaging like X-ray, CT, ultrasound. And this work is not only capable of detecting COVID, it is also capable of creating a difference between normal COVID and pneumonia. COVID and pneumonia has a problem that both of them, in both the cases, the oxygen saturation level decreases. So it's very difficult for the doctor to diagnose based on the subjective evaluation. So automatic detection of such distinction using deep learning network like COPS-CoVNet is very, very important for ensuring a smart health. This is the architectures. We are taking the slices from the ultrasound, and after some pre-processing, we are sending it to the network. And the network has 3 layers, like parallel concatenation block by the blue color, and then concatenated capsule block by the kind of reddish color, and the decoder block by the yellow color. So another work is very important because using musculoskeletal radiograph, because 1.7 billion people are suffering from musculoskeletal abnormality. So that's why we wanted to create an impact, developed a capsule network for abnormality detection, and this paper has been published in IEEE Access. My students have really participated at a very challenging competition in 2022, which is IEEE Signal Processing Society's flagship conference, ICIP. There the competition was held. The problem was very significant. You may have heard about different laparoscopic videos. In case of laparoscopic videos, there are a lot of distortion like white Gaussian noise, blur images, illumination level problem, and a lot of things, smoky frames like that. So to avoid the problem, fatal problem, it is important to find those distortion so that mitigation plans can be taken. For distortion classification in laparoscopic videos, my students have developed a DISNet network. So I have been an advocate of women and children for maybe more than 30 years. And it is really important that this vulnerable community suffers from skin diseases in healthcare, and they don't care about sharing this information to community or to doctors. So we are collecting different digital images of the carcinoma, melanoma, the type of skin problem, vascular lesion, like this. So we are also applying our deep learning and machine learning approaches to these images since 2017. We have a long way to go to have some success, although we published some papers so that these digital images can be sensed through app from any part of India or Bangladesh, and it can perform did perform the I should say it can perform the calculation, deep learning calculation in the server, and doctor can access it from any part, and can send the diagnosis results to the patient via mobile, SMS, or something. This is really very important for connecting the unconnected world to make it smart. There are a lot of neuromuscular disease like ALS, myopathy, like that. So we can easily detect it from muscle signal, which is called EMG signal. And for that, my students have developed LSTM and attention-aided CNN. And this is the proposed model architecture of LAA-CNN. And also you can see below the Conv1D block. And we are actually perform better model accuracy in training and validation. Left side and right side, we are getting less loss. That means our model is accurate. Same thing for multi-class classification, same thing for the objective results of compared to the other algorithm in terms of accuracy and sensitivity, we are doing good. We are outperforming others, okay? And it is really important in this noisy environment, in the practical environment, to have a speech enhancement technique so that we can use this speech enhancer in the hearing aid devices. That's why we have proposed a context and attention-aided residual unit-based deep learning model for monaural speech enhancement. This is our model, feature extraction stage and others, so that we can see how the noisy speech spectrum, noisy speech waveform is taken, and after some pre-processing, the concatenate features are sent to the model, and finally we will get the enhanced speech. And look at this car unit. We have used a convex net block between the encoder and decoder. And also this is a residual block, and this is our attention block, and this is our convex block. Look at the result. The first result is the noisy speech and noisy speech spectrogram. Second column is the predicted speech and predicted speech spectrogram. Third column is the target speech and target speech spectrogram. If you look and compare the enhanced speech spectrogram and target speech spectrogram, you can see they are both similar. And noisy spectrogram is very distorted. If you look at this picture also, you can see how this algorithm is working from different decimal level. My first row is minus 15 dB, second minus 10 dB, third row minus 5 dB. We can see the regular signal, we can see the spectrogram, and we can understand how our enhanced pitch output is close to the ground teeth or clean tooth. This is our final result. We can see compared to the other algorithm how we are performing. Left side is the subjective evaluation of Moss score. This is called mean if opinion score, how it listens compared to the other. And we can see also spectrogram. You can see the third column, the algorithm gives good spectrum to the target. Kindly, who is not speaking, would you please stop talking so that we can, I can deliver my and look at these different databases, speech, timid, and subak, and one of the speech data. Nayak, would you please see somebody like Usha Gupta is
Oh, one second, one second. कोई तो बात कर रही है। तो मैं नहीं हूँ ये कौन है रे उससे बोल के एक सेकंड
वही अपना सोल्यूशन
हाँ
समझा और फिर जो
Most
लोग
can
यूनिक
be-
करते हैं उस बारे में उनसे बातें की सिक्योरिटी पॉइंट ऑफ व्यू से सपोर्ट पॉइंट ऑफ व्यू
उससे
से
गुस्सा
आलू को
उससे कंट्रोल
अच्छे से दिखाया कि व्हाट वी
मुझे
आर
दे दीजिए ना
ही वाज एक्चुअली इम्प्रेस्ड
उससे
बहुत बहुत जबरदस्त मीटिंग ही वाज लोग इस ग्लोबल क्लाइंटेल और जो इनोवेशन और एआई में हम लोग कर रहे हैं really surprised that कि कोई सब पता ही नहीं था कि on that data set they can do so much.
Yeah, thank you very much. Can you hear me, Deepak?
Yeah, madam. Sorry, madam, for this.
No problem.
Okay.
No
Yes,
problem.
please,
So there are 3 different databases for speech where we have Libri, Timid, and Subak. One of them is a very
Hi.
big database. So we have
ओ
also
खाई दिखा दे वो रायता में
implemented our method for
रायता क्या होता है वो
speech Bengali database also, and we have compared our proposed algorithm with the state-of-the-art methods so that we can get a good results, and we are outperforming all of them. And this is a evaluation study that from initial to how we reach to our method and how we are performing. If you listen to this, yes, I'm not yet sure profound analysis, then the world has yet. This is the noisy signal and this is the clean signal. Yet his reasons have not yet been matured into express profound analysis than the world has yet seen. Now listen to the enhanced signal. Yet his reasons have not yet been matured into express profound analysis than the world has yet seen. That means our enhanced signal is very close to our clean signal. Yet not yet been matured profound analysis than the world has yet compared to the noisy signal. Yet his reasons have not yet been matured into Okay, so let us see that how we can develop a real-time world-level sign language recognition system exploiting GAN-based classifier. For that, my students have developed this network, and this is the example of image-based static sign language. Another is dynamic sign languages. So using a dynamic sign language, this is the video data. Now we are taking some frames and then finally we send it to the resonate and attention-based classifier to another, there is a GAN. The first one is the GAN and second one is the discriminator. And we are trying to achieve that. And for that, we really extract fiducial frames by media pipeline that can be used. And those frames are in very important rather than the static frame that is given in the left side. So we have taken the significant frames and significant fiducial point and landmarks. This is our model architecture. The first one is again generalized adversarial network that has been proposed as a generator, which works as a classifier, and below is a discriminator. And that really tries to prove that the generator is wrong. And if when it is not able to prove generator is wrong, then generator's output is taken as a final decision. So this is the overall training pipeline. This is again as a classifier. And then, unlike the conventional method, this model can detect the class as soon as few frames are received. That's why it has a capability of real-time implementation. So this is our overview of the data sets. 3 data set, 4 data set we have used. And this is our results compared to the other method, testing training accuracy, F1 score, and recall. Compared to the different methods, we are proposing a better one, and we can see the feature maps from different blocks of the proposed architecture and how we are performing. And finally, you can see the real-time deployment of the proposed architecture with a Python-based app. So we are going to more serious direction in a smart city and end-to-end framework for breast cancer segmentation and classification from mammography and ultrasound images. This is called breast DC GAN. This is our method. At first, we take the image and we find the region of interest. And once we have the region of interest, we find a cropped mask that is our target. So once we have the ROI and have the segmentation or mask, then we run the model as a classifier to get the breast cancer detection. We use it for, ultrasound images and other images, and we need data augmentation and pre-processing. This is our overall DC GAN, deep convolutional network for generator and discriminator, and this is our proposed generator. This is our ResNet 18 model for classification work that we have utilized. And this, we are having data set. This is our data set where we can see the percentage of the benign and malignant data. And this is our result, subjective evaluation, how we are cropping the image using the mask, and how we are preparing the mask to get it. Our loss is less, both training and testing, and also our accuracy is high, right side in training and testing, testing. Okay. And if we'll see our results in case of segmentation and classification, compared to the other methods, and also utilizing the same data set but our proposed method is using 2 data set, and you see the bold values, we are actually doing good for DISC score and accuracy, precision, and recall. Finally, we live in a community. We cannot utilize, and we should not utilize the data or a client in a hospital for a particular disease. That's why we have launched a personalized federated learning framework for heterogeneous optical tomography data classification using adaptive clustering and weight optimization. Look at this picture. First one is a training and prediction based on one hospital and find the model weight. But we are proposing to follow the right one. That means we will find the weight, and utilizing that weight, we will also utilize the data of other hospitals to find a new weight. Finally, all weight, updated weight, will be again updated in a server to give a prediction based on a particular disease. So this is a federated learning, which is technical system that aims to train machine learning model and use them through the collaboration and merging of various information sites without the need to exchange data. That means we don't need to exchange the data of hospital 1, hospital 2, hospital 2, hospital 3. Once we have weight based on the data of hospital 1, then automatically we can update the weights of the other hospital. So this is personalized federated learning. It's a special type of federated learning where the goal isn't just to create one shared model for everyone. Instead, each client, user, service, device, hospital gets a model that is personalized for their own local data. And look at this, how we are doing conventional federated learning and how we are doing the proposed federated learning. We take related clusters together. And you look at this, how we conventionally handle from the mother data set, how we go to the client data set. But in our case, proposed, we do not need to know all data sets. Those are all independent. So we have all mother data sets. If we have, this is our proposed deep learning model. And you can see there is a convolutional block, residual block, multi-head attention blocks. And performance metrics is accuracy, F1 score, and recall. And we are performing better for a OCT dataset. 2 OCT dataset we have utilized. And these are some values, comparison of different methods of personalized federated learning. And this is also different laws and like that. This is important that as we are doing good. And this is one round indicates after training within the client's global parameters have been updated. So this is accuracy and loss curve. And lower we can see the confusion matrices. So there are different OCT data sets are used, and this is heat maps that how we are doing in case of different images and how we are performing. Okay, so I want to thank you. So I have given you detailed information how deep learning can be utilized for healthcare to make our lives smart, and it can be part of a smart city. Without further delay, I want to stop here. I want to look for any question or anything. However, I know you will have some quiz questions. Hope you will. I tried to cover the questions so that you can do well in the quizzes. So any particular question, I'll be happy to respond. Thank you. Hello. Hello.
Please, anyone ask if anyone want to ask? Actually, first session only all are asking, madam. Second session all are tired, no? So,
No problem.
please.
Still they are
Ah,
attending. That is
yes,
important.
yes.
Recording will be shared to them.
Yes, yes. Already it's going on the YouTube also, and it will be shared, madam. Recording.
Okay, no
We have to
problem.
send to Atal also this recording.
Yes. So anybody has any question, you can ask.
Anybody, any?
They are all undergraduate student, right? Is there any
No,
postgraduate?
no, sir. All are faculty members only, madam. No student here.
All are faculty members?
Yeah. It is a faculty development program,
It is
so
a
all are
faculty
faculty members.
development program. It's not a web.
No,
Okay.
not students.
Yeah. Oh, nice.
And some are also there, like PhD scholars are only all. PhD
Okay.
scholars.
That's very good.
Maximum are faculty members only.
Then faculties should ask one question at least. I know.
Uh,
It's a Friday, last working day,
yes, yes.
and Diwali,
And
Deepavali is coming.
Diwali, yes, yes. We have Diwali, madam. So many will be going,
Yeah.
some traveling like that. From
Yeah.
Monday, actually, we have.
Yes, 20th October. Here we will celebrate
Yes.
here in 20th October.
You also celebrate there, madam, in
Yes,
Bangladesh?
of
Okay,
course. What you
okay.
hear, what you hear in the media, that's not the right one.
Yes, 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 yes.
We celebrate Durga Puja and this
Okay, okay.
and we celebrate Lakshmi Puja,
Acha,
Kali
yeah.
Saraswati Puja, everything.
Everything.
Yes, and Saraswati Puja is a national holiday for us.
Oh,
And
for you. Okay, fine.
mandatory for if a school, college, university to celebrate Saraswati Puja. Mandatory.
Oh, fine, 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 madam.
Yes.
Okay, madam. Romana, so thank you very much, madam.
Take
Ah,
care. I'm
I will
very
get back any necessity there. I will get back you, madam. I will
sure.
ask you that. Thank you.
For any
Yes, yes, yes.
faculty, career development, thesis evaluation, anything, conference,
Yes.
please let me know. I will be happy to support.
Thank you. Thank you very much, madam. I will get back to you.
Thank
Thank you.
you very much.
Thank
Take
you. Thank you. Thank you. Thank you. See, we will float now attendance link. Please wait 1 second. Please, it is the attendance link for today's second session. Please, you all fill up the second session attendance link. Please fill up the attendance link.
Sir, attendance link is in the chat box.
Yeah, yeah. I'm giving again. Please, did you get? Please fill up it. Actually, today, sometime before it has stopped. Yesterday was very late.